Set out on this road. What did you hope to discover? And tell us a little bit about what you covered in this study, please.
Right. Well, I think the senior representative from ONET, the Thai Environment Agency, summed it up really well in his final statement, where he said we need to think globally, analyze and assess regionally, and act locally. I really like that. And so we are working at the regional level. We've done analysis and assessment. We started out with three goals. One was to assess the threat, the climate threat to the region. The second was to then assess the impact of that threat on agriculture, livestock, fisheries, and other contributions to local livelihoods. And the third was to just provide some guidance to local action by starting to identify appropriate adaptation to the threats. Now, the extraordinary thing about this region is that it has such a depth of experience responding to climate extremes and climate variability. So there's built up in ecosystems, in species, and of course in communities, tremendous experience in adaptation responses. It might not be called that, but so the very positive thing about the study is the wealth of existing experience we found in the region to draw from and to act as the foundation for adapting to future climate. So that's a very positive thing. Other positive things came out that, in fact, we found that many fish species were resilient, many systems were resilient to future climate changes because of their natural capacity to cope with extremes and shocks. We found that many crops were very adaptable. So there's quite a few good news stories to come out of this climate change assessment. One thing that was debated over the last few days is that, or at least discussed, is that how depressing climate change studies can be. They seem to be so overridingly negative. And one reason for that is that you need to project out climate change to a future time slice so that its effects, it raises its head against the many background developments and other influences that are shaping this region, major development influences. And by the time you get out to that future time slice, in this case 2050, you find that the climate change influences start to be very significant. So we look at existing management responses, existing trends, but then we overlay a future climate on these existing management approaches and existing trends. So already there's a weakness in climate analysis because people say, wait a minute, we're going to respond. It's not going to be this management response now, it'll be a future. We'll incrementally adapt. Well, that's exactly the point, in a sense, that communities and governments will respond to the results of this study, and we're not predicting the future. All we're saying is that there are some potential influences of future climate, and you have to build that into your current planning and decision making. So I could just go through some of the findings of the study. We took a fresh approach, not a fresh approach, a fresh go at downscaling climate, and then expressing that in terms of the hydrology of this region. And the reason we did that is that climate change modelling, and Tarek is our expert here, and we've got all the other experts in the team here that they can answer your questions, but climate change modelling is evolving very rapidly. The models themselves and the way of using them and analysing them is evolving very rapidly, and we are part of that community, and we've learnt a lot. The modelling that took place 5 years ago, we know is flawed in the sense that the models improved and the analysis improved. So we took a fresh go at the modelling. We came up with a fresh set of projections for threat. Then the next step, we identified hotspots. So those hotspots went down to the provincial level, and of the what is it, Simon? 87 provinces in the Mekong Basin. We came down to a top of 20, and then that was further reduced to a top 8 provinces, hotspot provinces. Now, these hotspot provinces are areas which will experience very significant changes in rainfall, in temperature, and in flooding. Now, if we had decided to include poverty as another parameter, then we would have come up with different hotspots. In fact, I just talked to a very good research worker, Thai, who just finished their research, and they said, no, I looked at 5 hotspots in Thailand for the least vulnerable provinces, because that's where we learn where resilience is. So the point is that the hotspots are just to set priorities for the next phases of this project, which are for going down to community level, taking the results of the study and working with communities on their existing issues and problems, and seeing how we can use this new regional information to help them in their cropping and livelihoods. So we then had results. We then went down to these provinces, or worked on these provinces, and looked at agriculture. We looked at crop yields, crop suitability. We found, for example, that for rain-fed rice, the basic staple, out of the 8 provinces, 7 provinces will experience significant decreases in yields of rain-fed rice, which is a staple, very important commodity in livelihoods and local economies. For a commercial or industrial species such as Robusta coffee, widely grown in Central Highlands, we found that overall the Central Highlands will have reduced suitability for Robusta coffee, so a major commercial crop will see reduced suitability for its growth. But other areas will open up. So northeast Thailand, northern Thailand and parts of Laos will find that higher elevation areas now become suitable for Robusta coffee. So there'll be those kinds of shifts taking place in suitability. Interesting results for livestock, for example. We found that a key draft animal, a Bos indicus, was going to be stressed in certain areas of Cambodia and southern Thailand. Very significant reductions in their health and in their capacity to provide for drought services, because the conditions will be too hot, basically. They have a 35-degree threshold. We find that the average maximum temperature in certain areas of the region will go beyond that. So that's just one species. Generally, we found that disease in livestock would be more of a problem and be more intensively managed. In fisheries, we we found that the greatest impact will be on aquaculture. And for aquaculture, we feel is going to be in trouble. It's already now managed to the extremes, the limits of the aquaculture systems, and any additional stress could cause the collapse in all kinds of aquaculture, from very intensive to more extensive aquaculture. So that's mainly an export commodity, but in future, if overall fisheries productivity and yield in this region is going to reduce, which we feel it will, then it could be that a lot of that export needs to stay in the region to satisfy growing populations and ongoing demand for fish. I think a very important aspect of this study was that we looked at farming systems as including all of the surrounding natural systems, because all but the most industrialized agricultural systems have natural systems and natural products as a fundamental part of their products, their crops, if you like. So we looked at protected areas, we looked at non-timber forest products, many kinds, hundreds and hundreds of species are used. I think 700 in Laos of these wild species, 500 in Thailand, and in all countries they are a fundamental part of farming ecosystems. And in addition to these products, the farms receive important services. Pollination is one we don't really fully understand, but we know that most agricultural crops are pollinated by wild species, and that we could find that those wild species will be under stress in future climate conditions. So we looked at the various non-timber forest products. On the whole, we found that they had very significant resilience, built-in resilience. Some hibernate. Earthworms, for example, very important. Certain areas can burrow down 20 meters, and they go through a response to drought. So we found very high levels of resilience in wild species. The problem was, and this is where we came to probably the most difficult aspect of the study, is all of the other development influences going on. A lot of responses have been over the months from government people. Look, we can't cope with the present in terms of environmental problems. Don't tell us to talk about the future. And so how do we consider the 30,000 dams and structures that are now in place in this region, blocking various waterways? How do we consider that in fisheries? We just try to distill the impact of climate change. But when we overlay 30,000 structures, these are now part of the environment. 50 to 100 years, they're there permanently. So that was a bit of a challenge for the team, and the team still got that challenge, really, to how do we then come up with adaptation solutions that are not only responding to the climate threats, but are looking at an integrated approach that considers climate change as one factor, but also many of these other developments which are undermining the productivity of agricultural systems. So that's really a quick snapshot. The next stage is most important, is how is this information relevant to local communities? How can we communicate it in a language which is useful to them? And how do we first listen to their priorities and reshape our newfound knowledge from this scientific analysis so it's useful in meeting those current problems they have in a way which builds their resilience to future climate change. So I think that's the next step, and probably much more challenging than the one we've just been through.
Thanks, Jeremy. All this is not the end of the story. We're in the middle of the project now. Can you talk about where we go from here?
Sure, thanks, Jeff. Well, climate change is it's a complex concept, and we often hear about increases in temperature, increases in rainfall. And with each study that comes out, like the study that Nathan Mark has put forward, this really pushes the frontier of our understanding. But what's really interesting about the Mekong Mark project is it's really about the human face of climate change. The project now will go from the science that's been developed over the first year of the project to action, to actually going to work with the people of the lower Mekong. So the Mekong River Basin, which is composed of Thailand, Cambodia, Laos, and Vietnam, 75% of the population are farmers and fishers. And they are highly dependent on the river for agriculture and fisheries. So these people, what we say, are vulnerable. The Mekong River Basin itself is amongst the most vulnerable places in the world. So the goal of the project now is to take this science and link it to planning that's going to go on at the community level in 5 to 6 communities across the lower Mekong Basin. So really what we're trying to do is apply a climate lens. Communities have dealt with shocks for ages. They've dealt with economic shocks, they've dealt with environmental shocks. And they generally know how to deal with these things. They deal much better than people in the cities like us. But we're trying to give them the best available scientific information so that they can start making plans for their future. Now what's important in this is that in order to approach the communities, we can't just look at 2050. We have to look at what they're dealing with now. We have to look at the threats that they're dealing with and find a way to link that to the projections of the future. So what's really important about the study that's been commissioned now is that it doesn't stop here. It doesn't stop just at the research phase. We'll take the information and apply it. And this is, I think, one of the things that makes this study extremely innovative. So in the next phase of the project, we'll start incorporating climate information into the decision-making of communities. And that is a cyclical process. It'll have to happen over time, because changes will not all occur at once. They will occur over time. And what's really important about this is that the communities start to understand that changes are occurring. Not that they switch from one crop to another, but that they understand there's a process that is happening. So as much as anything, we're hoping that we can get the communities to act, to learn, and then to act again, because that is really an important component of adaptation. It's understanding that this is not all about today, but today does matter. And understanding that it's not all about tomorrow as well, but you have to plan for tomorrow. So I think that is what makes this project somewhat groundbreaking in its approach. And we are seeing a number of projects that are starting to develop like this. And these projects are beginning to share information. We're at a very early phase of learning about how to help communities adapt. And today, somebody in our workshop asked the question, can you give us examples of successful adaptation? And it was a challenge. And my response to this was, what does successful adaptation look like? We're dealing in scales that are broad, provincial, national, community, but you're also dealing with a time frame that's going to last over a long period of time. So what's successful today may not be successful tomorrow. And we won't be here to see 2050, at least the Mekong Arc project. Brad might, but the project won't. So my hope is that we can begin instilling an understanding of these changes for communities, that they can start developing strategies on their own, that they can then begin monitoring the impacts of climate change, and that they can use this information to think through what are their best adaptive strategies.
Okay, thanks. Tarek, before we open this up to the questions from media, the Lower Mekong Basin is a big place, and you guys zoomed in on some key provinces. Could you kind of walk us down the basin? What are some of these provinces where you focused and where this work might follow up? Thanks.
I think the first thing to mention is that the Mekong Basin is a really unique place to work. You know, when we're talking about climate change assessments, we're talking about usually climate change itself and also climate variability. And under both of those parameters, the Mekong is globally is really quite unique. And it arises from the fact that there are a lot of processes at the regional scale that drive the climate and hydrology of the Mekong Basin, and they vary throughout the region. And so what we find is that, for example, the Mekong Basin has 2 monsoon regimes, which is not usual in the world, that you would have 2 monsoons acting on the same location. You've got snow melt and glacial melt up in the Tibet and Chinese parts of the basin. You've got these storms that are coming out of the Pacific Ocean, starting in the Pacific and moving across the basin that way. So all of these factors create a very high level of seasonal and spatial variability in the climate and hydrology regime of the basin. So when we were looking at these hotspot provinces, and when we're looking at temperature and rainfall changes in particular, we try to do it in such a way that we can encapsulate some of this variability in the places that we're focusing on. And where we ended up selecting hotspot provinces based on the magnitude of the change. So it's really that we could consider them threat hotspots or exposure hotspots, because they didn't take into account, for example, the capacity of the system to respond to those threats. But where we ended up focusing was 8, as Jeremy mentioned, 8 provinces. And those 8 provinces were located, for example, Mondulkiri and Xialai, which is in the southeast of the basin. We had Kamuon and Sakon Nakhon, which is in the northeast of the Isan, and then into across the border into Thailand as well. We had Champasak, which is in southern Laos. We had Chiang Rai, which is up in the north of the basin. And how many am I doing now? Kenzang in the Mekong Delta. And
I think that's 8.
Is that 8? I think 7, yeah, so one more Kampong. Stung Treng, okay, Stung Treng, that's right, yeah, Stung Treng was the last one, thanks Tree. So these 8 provinces, if you look at their location on the map, they encapsulate all of these different drivers in different ways. The ones that are, say, for example, Xialai and Mondulkiri, they're right. If you look at the historic distribution of storms, those provinces are, right in the middle of the main tracks that storms take, as they come across from the Pacific Ocean. The Kamuon and Sakon Nakhon, they're very sensitive, or the rainfall in those areas are very sensitive to the strength of the monsoon. So those 2 provinces really pick up that kind of signal that we would be getting in the climate change projections. So from a threat point of view, I think we've actually come up with a very good selection of hotspot provinces, and they except for maybe the glacier snowmelt, but they capture most of the main kinds of drivers that we have in the hydroclimate system.
Thanks. And unless there's something that you're burning to say right now, I'll turn it over to the press. Okay. Okay, do we have any questions? Sir.
Peter Johnson, DPA, German Press Agency.